Alright, okay, ayan. So, hello dears. Ayan. So, welcome now to the part 2, the second video of our lecture on hay infusion, diba? So, the first part, kaysa loom lang siya. So, loom lang siya na version because again, there are some pictures there, GIF sila, na, so that I think it won't be clear. They won't be clear if I lecture it this way. Alright? So, again, hay infusion, we perform hay infusion so that we can look, or we can know the different groups of protozoans. And again, not all of the protozoans found in your hay infusion can cause disease, but there are groups there of protozoans that can cause disease. And that is now what we're focusing in our class this time, or in the second part of the lecture. And that is the medically important protozoa. All right, so I know I have already introduced this in the first handout, the introduction to clinical parasitology. But this time we're going now to go to different species na gyud of protozoans. All right, and then their different characteristics. Mo to siya. And I'm actually quite worried or quite doubtful, skeptical if I should continue with this type of information because I think it's too much for a laboratory class. Maybe it's all about lecture now, or like these topics should be discussed in lecture and not in the laboratory. But then again, I just, justified that, bahala na. As long as I get to introduce then these to you. And at least also, I already introduced it to you in the lab, and then once Ma'am Bernal discuss these in lecture, then you already know. Press the buzzer na, okay? Easy na. All right, again, so for protozoans, medically important protozoans, diba? Recall in our first handout, the 4 major groups of protozoans that infect man, starting first with, of course, your amoeba, all right, or the amoebae. Next, you have the flagellates, followed by your ciliates, or ciliate, and lastly, your sporozoans. All right. Now, for this lecture, what are we going to discuss? For the amoeba, we'll just focus on 2 species. You have Entamoeba histolytica and negligiafoli. The second one for flagellates, we're just going to discuss only 2 also. You have Giardia duodenalis and Trichomonas vaginalis. And lastly, for ciliate, of course, the only one. The only pathogenic ciliate, Balantidium coli. All right. And for the sporozoans, we'll not discuss it here because your sporozoans usually, they are not causing diseases in the intestines or in the genital tract. Usually, the sporozoans cause disease in the blood. Okay, so blood. All right, so there will be a separate discussion on this when we go now to the different parasites that can be found in blood. Okay, alright. Kaya pala, medyo hindi clear kanina. But anyway, yes. There will be a separate discussion for the sporozoans when we go now to our topic on blood examination for parasites. Alright. Alright, so we'll start first with the amoebae. Alright, just a general description, or, characteristics of the amoebae. It's under phylum Sarcomastigophora, alright, and subphylum Sarcodina. Okay, so you don't need to remember that, but I highly encourage you to be familiar with that. So if you forgot already this, di ba, nasa first slide natin, yung picture ng mga classes, okay, and mga phyla. Alright, now for amoebae, if you notice guys, if we go to the different types of protozoa or the different groups of protozoa, they are classified according to their, again, organs of locomotion or the way they move. What organelles do they use for motion? And for amoeba, they use what we call your pseudopods. I mentioned din sa activity natin, your microscopic, virtual microscope. They have what we call your pseudopods, which are extensions of the cytoplasm, all right, that allows them to move, all right. And pseudopods, the rough translation of that is known as false feet, okay. So they're not really feet, para silang, they appear like feet, okay. But these are called pseudopods, okay? Pseudopods. Again, which allows them to move in the environment, okay? So for amoeba, their organ of locomotion or for movement, it's your pseudopods. All right. Okay, then we also have 2 morphologic forms in the amoebic life cycle. So again, I've introduced these terms na din sa lecture natin on stool specimens, no, for parasite examination. The first one is your trophozoites, diba? As I've mentioned also, the trophozoites is the feeding stage, all right? The trophozoite is the feeding stage of your amoeba. So it's motile, and it consists of, or it possesses the pseudopods. Because again, it's motile. It needs to move, all right, to find food. Ayan. And lastly is the cyst, the non-feeding stage. It has a protective wall, which is usually thick, to protect it against the harsh environment. Okay, and it's usually this stage that is infective. So again, that's for this cyst. No, again, most of the amoeba, again, that is the infective stage, the cyst. But there are some amoeba that their infective stage is not the cyst. Okay, again, it protects the parasite from a harsh environment. All right, and again, the most common way as to how amoebas are transmitted to humans, it's through ingestion of the contaminated food and water that has the cysts. All right? Okay, so generally, most of the time, that is the most common mode of transmission. All right? Okay. Now, we'll start first with the very popular and again, the only pathogenic intestinal amoeba, that is your Entamoeba histolytica. All right. Again, the infective stage is your mature quadrinucleate cyst. So when you say quad, 4, nucleate, nucleus. So the cyst contains 4 nuclei. All right? Mature. All right, and diagnostic stages, again, the stages or morphologic forms of parasite that can be seen when you examine specimens, no? And for Entamoeba histolytica, it's both the trophozoite and the cyst. So you can see both the cyst and trophozoites, or trophozoite lang and cyst lang in the specimen. All right? Okay. And mode of transmission, again, ingestion of food and water contaminated with the cysts, with the mature cysts. But there have been reports, okay, there have been cases of sexual transmission through usually anal practices, mga anal sex, ganun. Yes. So, pwede siyang ma-transmit. But those are not common, okay? The pinaka-common jud is kani, ingestion of water or food that has the cysts. Okay. All right. And now, what are the diseases? Intestinal amoebiasis, of course. You have amoebic colitis, amoebic dysentery, and lastly is, of course, extra-intestinal amoebiasis. Okay. Now, what do you mean by extra? Yan, pabibo siya. Joke lang. Okay. When we say extra-intestinal, so the amoeba, the trophozoite, goes out of the intestines and infects the other organs. All right? Okay, so extra-intestinal, so outside of the intestines. All right. And when it does cause amoebiasis, it can cause a description or an ulcer described as flask-shaped. So flask-shaped, it looks like a flask. Erlenmeyer flask, mga laboratory flask, ganun. Okay. Flask-shaped ulcer. And aside from that, when it does go outside of the intestine, the most common site of extra-intestinal amoebiasis or most common involvement is hepatic involvement or your liver. Okay? Your liver. Nako, press the buzzer na. The most common site of extra-intestinal amoebiasis is your liver. Nako, yes. Lumalabas sa boards. Okay, all right. Ayan. And when it does go to the liver, it now causes abscess. Okay, so when you say abscess, mga hubag-hubag or swelling that has pus that contains nana, na ay pus sa sulod. All right? And for extra-intestinal amoebiasis, the pus that it produces, or the pus that is produced is described as chocolate brown, thick chocolate brown, wala me, joke lang. Or anchovy sauce, anchovy. Anchovy are like small fishes na parang smaller than sardines. Okay, so anchovy sauce, I'm not sure if ginamos ba na, but I think basta brown ang appearance niya. Alright? Thick chocolate brown anchovy sauce that's inside the abscess. When you say abscess, again, swelling that contains pus. Alright? Okay. Again, most common site of extra-intestinal amoebiasis, your liver. Okay, all right, ayan. And when it does reach the brain, it also causes what we call secondary amoebic meningoencephalitis. All right, so second ra siya, guys. First runner-up ra siya. Secondary lang. So of course, if na secondary, na po primary. All right, so we'll know later kinsa ng primary. Okay, but for now, Entamoeba histolytica causes secondary amoebic meningoencephalitis. So meningo refers to the meninges. Encephalitis, so brain. Litis is inflammation. So inflammation of both the brain and the meninges. Okay? Alright, ayan. And next, how do we diagnose? Wet preparation. So you process the stool, you get a stool sample, put it on a slide, add 1 drop of NSS, and then examine under the microscope. That's wet preparation. Our next activity, okay? And stain smears, we stain your smears so that we can view them. Culture using this medium, TYIS33, and serological tests. So using your serum and testing mga immune parts or immune components like antigens, no, antibodies. Yes, okay, all right. And this is a picture of a flask shape. So as you can see, it looks like a flask, di ba? Ayan. So para siyang flask. Okay, all right, ayan. Now we go now to the life cycle of your amoeba. So as you can see, it's very straightforward. It's very simple. Again, humans or the host ingests the mature cysts, all right? And inside the cysts, it now becomes a trophozoite, all right? And then it replicates, okay? And then becomes a cyst ulit. And then it's passed on into the feces. And then, of course, ready to infect another person or another host. And the cycle goes on. So it's very simple, very straightforward, all right? And once inside the host, it undergoes what we call excistation. So when you say X, so parang, yes, when you say X, cyst. So mugawas na siya out of the cyst, okay? So the cyst now becomes a trough, ayan. And of course, the opposite is encystation. It now becomes a cyst. The trough becomes a cyst, ayan. So excistation happens if the environment is conducive na for learning, for living. It's not that harsh. So the cyst becomes a trophozoite because your trophozoites are sensitive, they deteriorate rapidly, and they do not like harsh environments. But in the case, in the environment sa intestines, medyo acidic na, taas nag-pH, whatever, so it's not conducive anymore, the trough then converts balik, okay? It converts or it returns to becoming a cyst, okay? And that is known as your encystation. Because again, recall that your cyst can withstand harsh environment, okay? All right, ayan. So, very straightforward, no? Iyahang life cycle. It's not too complicated. It's usually through ingestion talaga, through eating. So, again, proper hand washing, guys, and be sure that your food is always safe. Okay, all right, ayan. Now, we go now to the different stages of the Entamoeba histolytica, the diagnostic stages, starting with the cyst. So, that's its cyst, theoretically based on our book, Zybig, and based on real specimen. Okay, ayan. So, that is its appearance, and it's described as, number one, the shape is spherical to round. So as you can see, it looks like a sphere or round siya. And aside from that, you have a chromatoidal bar, this one, that is described as coffin-shaped or round edges. Ang iyahang edge, kay round. Okay? Alright. Okay, chromatoidal bars, that's part of the parang chromatin, so part of their nuclear material. Aside from that, you have a central karyosome, this dot there. Karyosome is a mass, kumpul-kumpul of chromatin pa rin, so nuclear material. Central, so nasa tunga. And fine, evenly distributed chromatin. Alright, so clear, smooth ang appearance sa chromatin. Alright, okay. And may contain 1 to 4 nuclei, alright? And a mature one consists of 4 canuclei, alright? Okay, so this is the appearance. The one that's pointed by the arrow is the chromatoidal bar. Coffin shape, nako, characteristic, press the buzzer, okay? Alright, coffin shape, chromatoidal bars, okay. And next you have what we call, of course, it's trophozoite, so that's its appearance, theoretically. And this is the real specimen, okay? Alright, now for the trophozoite, it's described as having a rapid, progressive, unidirectional. So when we say unidirectional, one direction lang. Wow. One direction, RIP. Anyway, rapid, unidirectional, progressive. So progressive, pass. It moves fast, it moves snappy ba? Like it's not slow. Alright? Ang iyahang motility. And aside from that, it has only one single nucleus with a large dot at the center, which is your, again, karyosome. And aside from that, please take note of this sentence. The presence of ingested RBCs is considered to be diagnostic of Entamoeba histolytica trophozoite or Entamoeba histolytica infections. Okay. Now, recalling our activity in the virtual microscope, diba? Ilahang description is E-hist/E-dispar. Ayan. Now, recall again, how do you, what did we talk about or what did we say about E-dispar? E-dispar is a non-pathogenic amoeba. Now, what is the problem? Because they look morphologically the same, meaning their cyst looks the same, their trophozoite looks the same. All right. Now, that's why if we see this in this practice, in real practice in laboratory, we usually report it if we see like this, E. histolytica / E. dispar. Because again, they look morphologically the same. But if you are to be asked, if you want to differentiate the two morphologically, okay, how will you do it? You look at the cytoplasm of the trophozoite and look if there are ingested RBCs. Because only Entamoeba histolytica ingests RBCs, okay? And E. dispar does not, all right? So if your cytoplasm, your trophozoite, under examination, you see RBCs in its cytoplasm, then that's most probably Entamoeba histolytica. All right? Okay, but according to Bailey and Scott's Diagnostic Microbiology na textbook, no, there was a study conducted and they found out that 16% in their study, E. dispar also contains RBCs. That is why, and also patients also now that has Entamoeba histolytica infections, their trophozoites do not have RBCs or do not have ingested RBCs. So according to Bailey and Scott's morphology, comparing morphology is really complex and difficult. That is why to really confirm the two or differentiate the two, you need to perform molecular tests or mga immunotests, serological tests. All right? Okay. But again, in practice, in your internship in the future, or in practice when you become medical technologists, usually in the laboratory, they follow that if you see this, trophozoite ba or cyst, you report that as Entamoeba histolytica / Entamoeba dispar seen. Okay, all right, ayan. So that is for Entamoeba histolytica. All right. Okay, now we go now to the next and the last amoeba that we're going to discuss lang in the lab, which is your Negligia fowleri or fowleri. Now, your Negligia fowleri, its infective stage now is your trophozoite, may it be amoeboid or flagellate. Later, we'll understand that. Diagnostic stages, trophozoites in the CSF and brain tissue. And for flagellated forms, it's only found in CSF. Mode of transmission is inhalation or aspiration of water during swimming, dust or aerosols that may contain the trophozoites. And the disease it causes now, yes, siya ang primary, siya ang the best, okay? Primary amoebic meningoencephalitis, PAM. All right, and for the diagnosis, identification of the amoeba in the CSF or brain tissue, all right? And it's the only amoeba known to have 3 morphologic forms. You have the cyst, the amoeboid trophozoite, the normal trophozoite of amoeba, and the flagellated forms. So, nasa flagellate form. Okay. All right. Now, we go na to its life cycle. Ayan. So, as you can see, how do you get, or how do humans get Negligia fowleri? Now, as you can see, the cyst occurs in the environment. It now converts into a trophozoite or a flagellate. Now, this one is what infects humans. So, how? Through swimming, ayan. So, mga diving, mga snorkeling ba, whatever. Any water activity that could introduce water into your nose, okay? Because dira siya musulod, or it's the point of entry, all right, of your Negligia fowleri is to the nose, all right, the trophozoite. Now, let's say the water contains trophozoite of Negligia fowleri, and then swim ka dyan, swim, and then you were able to aspirate water into your nose. Ayan. So, the trophozoite then penetrates your nasal mucosa and then infects the olfactory nerve and then travels to the brain. Ayan. And usually, this is deadly. It's usually, the prognosis is not good. It can lead to death. So, yeah, I've seen a real case scenario of Negligia fowleri infection in Monsters Inside Me, guys. Ayan. So, this is a TV show. Yes, may pa-promotion. This is a TV show in Discovery Channel. I'm not sure if it's still ongoing now, but there are, mga pirated, piracy, yes naman, no to piracy, but yes, mga poor, salig sa piracy online. So there are episodes of Monsters Inside Me, and there was a case of primary amoebic meningoencephalitis, Negligia fowleri, and I think the patient was a boy, 11 to 12 years old yata, and he eventually died, yes, unfortunately, because again, nag-swim lang sila sa lake, no? And then, after a while, after pila ka days, na-experience na siya symptoms like nausea, and then all that, and then na-coma siya, I think, and then eventually led to his death. No, so kayo guys, if you are really interested and enthusiast in swimming and all that, just make sure that the water that you're swimming is not unknown, it's not parang murky or not parang basta, like that. Just be careful, yun. Okay? I'm not sure if there have been cases of Negligia fowleri here, but yes, it's a common in the US. All right. That is why, as you can see, it infects the brain. That is why your Negligia fowleri is also known as your brain-eating amoeba, if you're familiar. Brain-eating amoeba. Okay? Alright, ayan. So again, through the nose. Usually through the nose ang point of entry sa Naegleria. Alright. Okay, now we go na to its different stages. First is the cyst. Ayan. So as you can see, general characteristic, thick wall, spherical, but it's not seen in brain tissue. So it usually resides lang in the environment. Alright? For the trophozoite, this is the amoeboid. It has 3 forms. Of course, slug-like motility, broad at the anterior or at the front, and then tapered at the end, meaning naniwang siya at the end. And then granular cytoplasm, as you can see, daghang parang busot-buslot, or there are so many circles. Those are also your vacuoles, okay? All right? And slug-like motility or slow ang motility niya. And lastly, its flagellated form, pear-shaped, jerky motility, like jerky, okay? Magkurog-kurog, all right? And it only happens or appears when adverse environment changes occur. So although it has a flagellated form, it's still an amoeba, guys. Do not be confused. Bahalag na siya flagellated form, it's still an amoeba. It's just that it has this form whenever there are changes in the environment. Okay? And once the environment is okay, from the flagellate, it now becomes the amoeboid. So it just converts. All right? So the flagella here retracts, it goes inside, and then becomes an amoeba na pod. Once the environment is okay. All right? Ayan. But again, generally, it's still an amoeba. Do not be confused by the flagellated form, It's still an amoeba. Actually, your negligiafoli is known as a free-living amoeba or an opportunistic amoeba. When you say free-living amoeba, under normal circumstances, it just lives there in the environment, like peacefully, malinawon, okay? But when it is introduced to the body, it can become deadly, can become pathogenic. All right? Okay. Now, for the next video, or next part na good, hopefully the last, we'll discuss now the last remaining groups of protozoa, medically important protozoa, starting with your flagellates. All right? So I hope na gets lang so far. All right? And I'll see you in the next video. Okay.